Hi, in this video we are going to look at various ways to go deeper into feedback patching using Joranalogue modules. This video is meant as a follow-up to my previous video called 5 Levels of Feedback Patching using Joranalogue modules. Today we'll explore methods to add complexity and nuance to feedback patches, as well as compositional strategies when working with feedback. Some of the latter include ways to develop compositional sections and variations within feedback patches. Along the way, we'll do a variety of patch programming to attain certain behaviors we need from the modules as well. The overarching idea here is simply to share some of my own approaches with you, including techniques I've learned from others, in hopes to give you more tools in your toolkit or spark ideas of your own. I'm going to break down my patch construction into 10 steps. For step 1, I'll patch up Ian Fritz's Traveling Wave Chaos, which is a simple chaotic patch I introduced in my previous video. This is simply a through zero FM oscillator in feedback with a filter. However, you can do this patch with any oscillator, even if you don't have one capable of through zero FM. In my version of the patch today, I'm going to use Generate 3 in feedback with Filter 8. To patch this up, I'm going to use the full output on Generate 3, go into Filter 8, and I'd like to use the high pass filter out today. I simply know I really like that output in this configuration. Of course, you can explore any of them. I'm going to take the audio from the bandpass out, and I'll insert fold 6 into the audio signal path because it sounds great and for more timbral control. I'll use Xpan for a simple VCA. And let's listen to this. So all kinds of interesting sounds right out the gate with this patch. And I'm not going to be too precious with them just yet because of course they're going to change a lot as I build on this patch. To pause and think compositionally for a moment, we could stop here and record these sounds and layer more recordings later. I'm actually doing this in some pieces I'm working on myself right now. But today I'm more interested in building a patch that is self-playing and is closer to a composition itself. And with that in mind, let's move on to step 2. For step 2, I'll insert warp 1 into the feedback path. I'm going to use warp 1 to continually shape the signal responsible for feedback. This idea came from DivKid's video on warp 1. There's a point in the video where he talked about wave shaping your audio rate modulators. So I thought it would be cool to wave shape the signal that is actually responsible for the feedback loop. If we take the high pass out from filter 8 and go to the input on warp 1, and now reconnect the feedback path, so warp 1 out into the 0 FM on Generate 3. Let's first take a listen to that. Kind of put these in more neutral settings. And here we go. Of course, this could become more interesting if I modulate these parameters. Today, I'll keep the modulation to a single parameter by modulating just the exponent with orbit 3. Of course, you could take this a lot further by modulating other parameters or patching more feedback between all 3 of these modules comprising the feedback loop. So I'm going to use orbit 3 to modulate the exponent. So as you can hear, there's a variety of sounds emerging as we adjust the depth of the through zero FM. And this brings us to step 3. For step 3, I'll insert step 8 into the feedback path. Let's run the output of warp 1 into the input of step 8. Gonna have to get a longer cable. I'll take the scan output and run that back into the through zero FM input. I will leave step 8 in tracking mode so the input is constantly passing instead of behaving like a sample and hold. Alright, it took me a moment, but I've arrived at an interesting sound. And now let's step through step 8 and see if we can get some variety. So now, our feedback path starts with generate 3, then to filter 8, then to warp 1, then to step 8, and finally back to generate 3's through zero FM input. On to step 4. I'd like to clock step 8 so that we can step through those various depths of feedback, and I'd prefer for that signal to be derived from within the patch so far, rather than something entirely new and unrelated. If we tried to use the oscillator as our clock, and plugged it directly in to step 8 step input, the clocking is a bit erratic due to the feedback loop and the constantly fluctuating frequency, as you can see here on the LEDs. We could work with this, but I would like to kind of reduce this erratic behavior. In my last video on feedback, we used Compare 2 to help fine-tune the triggering of step 8, but this time we'll use Contour 1 as a clock divider. And we'll clock divide the oscillator signal. So let me patch this up. So I would like to use the fundamental output of generate 3, which is a sine wave. So I'll run the signal into this left input on the top channel of select 2. And then I'll pass it on to this Contour 1's trigger input. Now I will not allow this signal to pass during the rising stage of contour 1. So I'll take the rise gate output and plug it into the select 2 input. That way, when this signal is rising, as you can see on the LED here, our oscillator is not allowed to pass. So it's clock dividing. It will only pass once it's finished rising to its max voltage. So we've patch programmed a clock divider here. Now I'll take this fall output and plug it into our step input on step 8. So as you can see, our clocking behavior is a lot less erratic. It's still not like perfectly symmetrical, and that's great. I want it related to what's happening in the feedback. I want it to be a product of the feedback. So let's have a listen. I prefer to work with odd numbers most of the time, so how about we make our step A behave more like a step 7? I'll take this 8th gate output and plug it into the reset input. When you use one of the stage gates to reset the register like this, you can think of it like a wall. The gate output is responsible for resetting and blocks the further progression, as we can see. So this is pretty cool. I'm happy with this patch so far. Next up, for step 5, I'd like to reorder the filter and wave folder signal flow with pivot 2. So to construct this patch, I'm going to have to first run the oscillator output we were using into pivot 2's main input. Now we'll start patching up the filter and the wave folder. First, the filter. We'll send the signal into the filter. Then we'll return that signal, which was this bandpass out. Now we'll complete the wave folder side of this. Take that main out and pass it through the return. And now take the output and go on to XPan. So now that I've completed the patch, what do we have here? So when the pivot knob is in its leftmost position, we have the same signal flow we had before, where generate 3 goes to filter A and then to fold 6 and then XPan, which we're using as a VCA. If it's in the rightmost position, fold 6 is placed before filter 8. And any other position on this knob means we're getting some kind of parallel processing. So let's listen to this. So this is what we had before. And now we've flipped the order of fold 6 and filter 8. Of course, we could use pivot 2 in other places in our patch, but this is what I decided to do today. So now let's actually modulate this pivot 2 control. I could use a variety of signals to explore the parallel, in series, and everywhere in between routing that pivot 2 allows, But in this case, I'll use some of step 8's stage gates, and I'll use add 2 to combine them into one signal. So let's just pick a couple of gate outputs. We'll add them together using add 2. And we'll go from add 2 into the pivot control input. I use add 2 to combine or stack gates like this quite often. It wouldn't happen in this scenario, but even if the gates were active simultaneously, you wouldn't have to worry about them being too high because of the output being limited to 12 volts by the Eurorack power rails. So right now, with the combination of our knob settings here and also the fact that we're using a gate input, we're actually just exploring 2 in-series signal flow options. The one that has filter 8 first, and then the one that has fold 6 first. What I like about this technique is it has helped some of our steps have more difference between them, which gives our pattern more complexity. For step 6, let's modulate the panning. I often will use a signal already core to the patch, like even the oscillator itself, but let's incorporate orbit 3. So this already sounds more engaging to me with the stereo movement, but orbit 3 is sort of sticking out as unrelated to anything in the patch. So to help tie it in, let's modulate its frequency with something important in the patch already. I'll try the core output of generate 3 at first and see how that goes. I'm liking it so far, but I want to just explore some more positions along the knob. Whoa. Faster is kind of cool. Okay, I'll leave it there for now. In the previous step, we added orbit 3 for panning modulation. For step 7, let's add delay 1 into the audio path. That's pretty cool in the kind of almost lowest setting. So how about on certain step 8 gates, or even perhaps the exact same gates we're using to modulate pivot 2, let's modulate the blend parameter to bring in the wet signal. So I'm liking these results quite a bit so far. We could, of course, modulate more of delay 1's parameters. There's a lot to explore with every module we add in, but let's keep it relatively simple so we can focus on other areas. So this brings us to step 8. No, not the module, but the 8th step in the progression of our patch building. I'd like to shift our focus to larger, more macroscopic ideas concerning compositional form. I'd like some kind of operation to cause a larger change in the patch, one that is clearly new and a departure from what has been. To get started, I'm looking for something that can operate at a slow pace, but once again, I'd like it to be connected to events already occurring in the patch. What I've decided to do here is to use another contour 1 as a clock divider, and trigger that contour 1 via stage gate 1 of step 8. This contour 1 will behave as a counter, counting how many times we've gone around the full register of step 8. So I'll patch that up now. I'm actually going to bring in another contour 1, which will get triggered by this one's fall gate. This contour 1 will be responsible for the more macroscopic change. So I'm going to try using its fall output and maybe its main output to control certain things in the patch that'll make a more significant change. So this one, once again, is being our counter. You can see how it takes a while to reach its full voltage, and then the fall output triggers this one, which we're going to use more as an envelope generator. So I'll try using this contour 1's fall output to modulate the exponential FM on our filter. And the longer we make the fall time, of course, the longer this event lasts. Let's try the main output, modulating the resonance control input. So let's slow down our count so that this change happens a lot less often. I want it to feel more like a sectional change or a variation in a phrase, something similar to that. So obviously this needs to last a lot longer. Let's just listen carefully and see what happens once this reaches the high voltage. To keep our two contour 1 signals from overlapping and working at the same time, I'll freeze the contour 1 that is acting as our clock divider or counter. by patching the fall of the second contour one into this one's hold parameter. This will keep their operations separate, meaning the first contour one will stop counting as the second contour one is active. Let's try it. So when this contour one is in its fall time, let's see if this contour one gets triggered. It should have just been triggered and it did not respond, so this is working correctly. So if we wanted to have more flexibility with the length of our rise time, we could combine both the rise and the fall gate outputs with something like add 2, and then take the signal into our hold input again. And then we have extreme flexibility on how long both rise and fall times can be. But in this case, let's keep it simple. I probably don't want a really long rise time anyway. So as I said, I'm thinking about this as two different sections in a composition. For the sake of this video, I don't want these two different sections to be over a minute each. So I've set the rise on this contour 1 and the fall on this contour 1 to not be too long. So let's have a listen. We're in the first section. And here's the second one. Back to the first. Second. So imagine if we really took more time here and maxed out these fader positions or applied offsets to them or something like that. We could get really long sections if we'd like. And of course, we could add even more changes that occur within those sections. So that's to get you thinking a little bit more compositionally or macroscopically. Is that a word? This next idea is taken from one of my favorite YouTube channels, La Synthèse Humaine, where Gunnar Haslam patches up a method to explore the average rate of change in a feedback patch. I'll include a link to the video in the description. In the video, Gunnar patches the audio signal into the surge-peak circuit. The peak compares voltages and outputs the highest, aka the analog maximum. It has a 0-volt floor, so when Gunnar plugs the audio signal into the peak alone, the output is a half-rectified version of the signal. In my system, Warp 1 is an easy way to do half or full wave rectification, but I've already used it in this patch. However, off-screen to the right, I have a Morph 4 which can do rectification as well, which is a patch documented in the manual. I'm going to take our audio signal from pivot 2, which is before it goes into delay 1. Of course, I could choose to take it from here instead. And now I'm going to use a really long cable to connect Morph 4's maximum output, to the select 2 input. So in Gunnar's video, he uses a voltage processor, and that's what we're doing here. And we're going to bring it to full unity gain and keep the signal unipolar in the positive domain. If you look at the LEDs on select 2, you can see that it's fully positive since it's only red. So that means our half-wave rectification appears to be working. Now I'll patch a copy of this output from the rectifier into another contour 1, which we're going to use as an envelope follower. So I have the controls here set up so it's behaving like an envelope follower nicely. Now I'm going to take this output and patch it in the second channel of our voltage processor, which is select 2, and fully invert it. So as Gunnar explains, this subpatch creates a crude high-pass filter that is roughly measuring the average rate of change in the audio signal. In his video, he uses the output of the voltage processor as a cybernetic regulator. I'm actually going to use it differently, and perhaps it's an odd use case, but I'm going to modulate the rate of contour 1 serving as a clock divider, which is advancing step 8. So I'm doing this because I would like to loosen up the timing a bit with a signal derived from within the patch, and thought it might be nice to try out this technique. So I'm going to take the output of this voltage processor and plug it into the rate input on our contour 1 that's serving as our clock divider. The clock divider that is then clocking step 8. So I think we're getting a little bit of variation now in our timing. It's subtle, but it's quite nice. Finally, for step 10, our final step, let's further develop the patch formally with the help of walk 4. As you might recall, this contour 1 here is largely responsible for a distinct change in the patch, a compositional change. What I'd like to do is use this fall output to trigger a channel on walk 4. Walk 4 is a voltage accumulator. When it reaches its max voltage, I'd like it to cause another shift in the patch. Walk 4, though, doesn't have a reset output. Has a reset input, but not an output. But I can use compared to patch one up myself. First, I'll take this fall output and trigger the first channel on walk 4, and I'll run the output of the accumulator into the first channel on compare to. It instantly went high because at this exact moment we happen to be in that window. Let's turn up the trend parameter. So I actually moved these faders down a little bit so that our sections would change more frequently, so that we can test our idea a little more quickly. Okay, so right now the accumulator output, well, it was too low. And now we're right in the window, now we're out, now we're too high. Still too high. Every time this fall output goes high, we trigger walk 4, which means we begin accumulating voltage determined by the trend parameter. So you can see us going in and out of this window right now. So we're too high right now. Let's watch this fader down here as well. Alright, now we're too cold, we're too low. Here comes another one. We're still too low. We can actually, a little trick is we can use this other channel to kind of see where we are. And right now we're in the window again. Now if we, because of the normalization, use this other channel, we can see we're quite high right now. Now we're out of range, but if we increase the size, we would see up there. Now we're too low again, we're down here. here. And then the next one, I bet we go high. Let's see. Yep. All right, so now let's slow our sections back down a little bit at least, because we have this patch working correctly. We've kind of patch programmed our own reset out. I'll take the out of compare to and plug it into various places in our patch. Remember, the goal here is to create another section in our composition. That's why we're using walk 4, so it will slowly accumulate over time, and then this new section will occur. So I'm looking for places to patch that create more significant change. At first, I'll try the exponential FM input on generate 3. To hear these changes instantly, I'll turn size up. Let's try the fold parameter on fold 6. So when compare to is low, compare to is high. That's pretty cool. Let's maybe try one more. Volt per octave on filter 8. Okay, let's now listen to all this in the context of the patch. I believe our contour ones are still operating at a bit of a faster pace, so we'll hear these sections more quickly. So right now we're in that special section that I'll call our C section, since it's our third kind of macroscopic change. Now we're back to section B. Oh, now we're back to section A. B. A. B. A. C. There's other ways of looking at this, like we could have a C1 and a C2 or two different versions of C depending on which one of these are high. Anyway, now we're back to A again. I wanted to quickly mention that you could integrate a manual switch like switch 4 for helping yourself out when you're editing the patch, because you could mute some of these outputs like the fall output, the comparator 2 output. You could run it through switch 4 and mute those outputs so that you could stop those formal changes from happening and things like that. That could help. And of course, you can also just tweak the parameters in real time like I was doing today. In closing, I'd like to just let the patch play for a while. But before we listen, I wanted to introduce my friend here, Mooney, who has joined us for this entire journey. My other cat, Sunny, was behind me in my desk chair for a while, but he eventually left. But Mooney's been asleep the whole time, or going in and out of sleep. Also, I wanted to say I hope you enjoyed the video and that it gives you some ideas for exploring feedback further and some compositional approaches. Please hit the like button and subscribe to my channel to be notified of more videos like this. Alright, let's have a listen.